All right, I gave you out this Chapter 2 written test last week, and nothing has changed, all right, except for the fact that what I decided to do, I'm going to go over Chapter 3 today. It should take about an hour, I would guess. All right, tomorrow I'm just going to go over Chapter 4, not 4 and 5. Just 4 tomorrow, 5 Thursday, and 6 on Friday, all right? And what I'll do is, in case you wanted a little bit more time to update your electronic portfolio, I'll take that through Friday, all right? Because it depends on what you want to do, okay? And I don't know how much, you remember Bootstrap or how much, you were given to begin with or whatever. So again, today I'm going to go over Chapter 3. You will get a written test for Chapters 3, 4, 5, and 6. Got the ones written for 3 and 4 already. All right, I'll give out 3s at the end of the lecture today. Give out 4s at the end of the lecture tomorrow, etc. 5 and 6, I'll make them due next week, like Monday. So you should have plenty of time to work on all this stuff. All right. If we keep up with that now, all this means is we're going to begin the code first and database first stuff on Monday instead of Friday. That's all. All right. So with that, I'm going to jump into Chapter 3. Oh, I should mention this. I'm glad that came up. All right, I just sent this out to all of you as well. If you didn't know it, the rank and test notification system sent something out this morning. You should have gotten either a text or you should have gotten an email. If you didn't, you may not be signed up. Even if you signed up a year ago, you've got to sign up again. Remember, it's Rankin's policy for whatever reason that what they do is if they are canceling class for a day, they do not send that information to the TV stations or radio stations or wherever. All right. So if you have not signed up, you can click the link and you should be able to sign up, upgrade your account, whatever it is. Okay. All right. So with that said, I'm going to jump into Chapter 3. There's a lot of stuff in this book that once we get into working on the project and stuff, you might say, do I need to do this? I'm going to try to keep what you have to do down to a minimum. Some of the stuff that's discussed in this chapter is pretty heavy. They talk about dependency injection and a few other things. We're going to try to keep that down to a minimum as far as the way we talk about it here and as far as what you have to do for your projects, etc. All right. So if you notice that this chapter is about the MVC architectural pattern, domain models and repositories, creating loosely coupled systems with dependency injection, and testing. We're going to do virtually no testing in here. All right. Now that's kind of a lie because every time you run a program, you're testing it. But we're not going to be writing unit tests and regression tests. That could easily take up an entire class itself. So we'll talk about them. All right. And in the sports store project, they actually have you in your solution, they have you create 3 projects. And one of the projects is for unit testing. I'm going to have you create that project, but we're not going to put anything in it. Throughout the textbook, what the author does is he'll talk about something, and in virtually every chapter, he'll say, now let's write a unit test for this. So if you decide you want to do that, you will have the project set up so you'll be able to do so. But I'm not going to make it at all mandatory. All right. They mention here that Model View Controller is not unique to ASP.NET. In fact, it's about almost 50 years old because with the advent of the Smalltalk programming language, all right, was really interesting. Years ago, I went to a seminar that was it was in Milwaukee, Wisconsin, and there was a guy walking around there. Anybody know small talk? Anybody know small talk? And no one did. So then later, same guy was walking around, I'm not making this up. Anybody want to learn small talk? Anybody want to, I'm just kind of laughing. And he's like, minimum 85 grand a year to start. We'll move you to Boston. And I actually gave it some thought. All right? Because I always loved the Red Sox. But that's a dumb reason for quitting a job and taking a job in another state. So, as I found out later from my wife, it's a good thing I didn't do that. So, you've heard some of this stuff before. You've heard about how MVC forces that separation of concerns. I have likened the separation of concerns that you have between model view and controller in a similar vein to what we did in the first semester with HTML, CSS, and JavaScript. All right. As far as the MVC pattern itself, you should have a fairly decent idea by now of what models are, of what views are, of what controllers are. I probably have said this to you before in some other class, but if I have not, if you were ever asked that, I'm not saying you will be or you won't be, you could always go up to a place like Wikipedia and type in model view control pattern 2. All right, and find out more if that was your desire. All right. At the heart of the whole thing, really though, when you look at it, is the model. Because the model not only holds the data, the model basically has all the program logic in it. And that's what the author talks about here. Again, I don't want to sit there and read this stuff to you. But what the author is going to talk about first here is the domain model. And after that, what he will do is he will compare and contrast using model view controller with other different design patterns that are available. All right. So he says here the most important part of the MVC application is the domain model. All right. We create the model by identifying the real-world entities, operations, and rules that exist in an industry or activity the app must support, and that's known as the domain. And again, with most of the stuff we will do in here, the domain will end up being a database. All right, and that database, as you would guess, would have tables in it. All right. Now, they mentioned that most of the time when you create a model from scratch, you'll sit there and you will right mouse click on the models folder, all right, and you will choose, new item, and then you'll go down and choose class, or you can do it another way, and they talk about that in here also. But notice what they say. In short, a domain model is a single authoritative definition of the business data and processes within your application, and it persists. That's why when most people think of models, they think of a database, because a database persists. All right. Now, they do mention here, it says, a common way of enforcing the separation of the domain model is to place the model in a separate assembly. What some people do is they take their model, and rather than having, model view controller, rather than having all their model stuff inside of the models folder, they make a different project. All right? And they put it in there. Not only that, you'll hear about this, in a little bit, but it's possible that the model can hold two different things. It can hold the data, and it can also hold the rules that work on the data. So what some people do, some programmers do, is in their models folder, they literally, what they put in there are all the rules that work on the data. But then, rather than actually putting the programs, or the tables, etc., in the models folder, they create another folder, and they put the stuff in there. The only reason I'm telling you this is sometimes you see this. In fact, a lot of times when developers do that, the folder that they put it in, they give it an acronym of DAL, which stands for Data Access Layer. All right, you may see this again some more further as we go on in here. All right. So, it says in MVC controllers are C# classes. They're derived from the system.web.mvc controller class. That shouldn't be anything new to anybody in here. All right. Each public method in a class is known as an action method. Most of the stuff we've looked at so far have either returned, we changed the type from action result to string or whatever, or we just returned a view. There's other things that can be returned also, and we'll talk about some of that stuff as we go on. Here's the author's picture of this. I'm not really going to sit there and disagree with anything the author has in there. I've mentioned a couple things to you before, such as, first of all, you notice there's no direct communication between the model and the view. If you write your stuff in a true MVC-like format, that's the case. All right? And second, one thing this really doesn't show in here, says the request goes right to a controller. No, the request rather goes to the routing mechanism. The routing mechanism is going to figure out what kind of controller should be called. What you will see as we go on is your route config file will expand as we get more controllers. All right, if we want to be able to automate things. Again, we'll talk about that a little bit later. All right, so the author says the ASP.NET MVC framework uses a view engine. That's the component responsible for processing a view in order to generate a response file for the browser. What used to be used in here were ASP.NET web pages. When I taught this class a couple of years ago, that's what we did. All right? And when you created, what happened was when you created your different classes and the like, you'd have two files. You'd have a .aspx file, which would be the GUI of the way yours looked, and then a .aspx.cs file, which had the code in it. All right? That stuff has been replaced as of MVC4. It has been replaced with using the Razor engine. We've talked a little bit about Razor. It'll be the next chapter as well. We'll talk about it some more. All right? Says there ASP.NET MVC doesn't put any constraints on the implementation of the data model, so you can do it any way you want. In other words, it doesn't have to be a database. Quite often it is a database, but it literally could be a spreadsheet that you are working off of, for example. All right. Now, the next section, as I mentioned previously, is going to come in and compare MVC to other patterns. You may have heard the saying, and maybe I've even said it, I don't know, that, a right tool for the job. All right. As far as, again, I think I've said this to you before, that I suppose if you really wanted to and you hit a nail hard enough with a wrench, you could probably pound it into a board. But that's not really the right tool for the job. All right. In much the same way, the author goes to kind of great lengths in here to say, MVC might not be the right tool for every job there is. If you're creating a very, very, very simplistic application that will never change, MVC is probably overkill. You probably don't need to do it. All right. Not only that, there are variations of MVC that we'll look at in just a minute. All right. So the author says, to talk about some of the different ones, first he mentions here the Smart UI pattern. That's a Smart User Interface pattern. That's pretty much the way we used to teach this class. In other words, what you would do, it's kind of like the C# class, really, when you think about it. All right. Most of the work that we did with the C# class, most of it, we did when you were kind of painting GUIs, putting buttons and the like, drop-down lists, etc. in there, and putting event handlers behind the button click event, the drop-down list event, etc. Would you all agree with that? All right. But one of the things that it was hard to do, I'm already writing my notes for the C# class that I'm going to be teaching in spring. All right. And one of the things that's hard to do when you use a UI pattern like that is, believe it or not, it's very hard to write a lot of tests. If we do a payroll program, you've done these, you did them in C#, and you do the payroll program and you do something like this, where you've got right here, so I've got first name, last name, hours worked, hourly rate, gross pay. We'll just keep it simple like that. You put in this stuff, you click here to calculate, maybe you got a clear, and you've got an exit. Okay? Everybody gets that, right? I don't know if you agree with this or not, but if my goal is to take this program and be able to use this program to test while loops, it's kind of hard to do it with that. And the reason it's kind of hard to do it with that is when you write programs that are GUI like this, they are totally under the person running the program. They are totally under their control. On the other hand, if you remember what we talked about before these, we did a little bit of work with console programs. In fact, I even made you on your first test or two take one of the examples that you did and write it as a console program. It is much easier to go and write tests for a console program than it is for a GUI program like this. All right. In fact, believe it or not, in MVC talk, when you use a pattern like I just showed you here, this user interface pattern, it's known as the anti-pattern because they say it makes it harder for you to do things. And that's pretty much what the author talks about in here. He says that it's ideal if you've got a very small sample project because you can get it up and working real fast. So if I want to come up and demo something, it's a real fast way to do it. All right? But if it's going to be very complex and have a lot of different things in it, so to speak, it's not usually the best way to write. All right? So the author says the biggest drawback of these smart UIs is they're difficult to maintain, they're difficult to extend. All right? So the thought was, okay, then let's create something else. Let's extend this and make it easier. And again, if you look on the screen or on the bottom of page 54 in your text, all right, notice what we have here. We've got a model view architecture. What's missing? What's not in there that we've been talking about? Controller. All right. What that means is either some of the logic has to be built into the model or some of the logic rather has to be built into the view, or both. All right? So the author says the area in which maintenance problems tend to arise with the smart UI is in the business logic. All right? So an improvement, it says, is offered by the model view architecture. It pulls the business logic into a separate domain model. All right? And you might say, well, that makes total sense. No, not really. But the idea is this. You typically, when you write this, you end up putting all the logic, everything. Not only the business logic, but there has to be, notice this, there has to be direct communication between the model and the view. This breaks what I told you is true MVC. But if you're not going to have a controller and you only have a model view, the two have to be able to communicate with one another. So typically when you write this, you get a very bloated model, or sometimes what's actually called a fat model. All right, because you end up putting everything in there in just a bare minimum in your user interface. All right, so they said, let's make it better than that. So then they came up with the 3-tier architecture. In fact, with the 3-tier, it used to be that the 3-tier architecture was called client-server. Now it's basically just referred to as 3-tier. And when you look on the screen, and I'm sure you all are, when you look on the screen, what you see here is what I mentioned before. You take the model and you separate it out so that the model logic is in here and the actual domain, all right, your data, etc., is put in a separate area known as a data access layer. All right? So as it says, this 3-tiered architecture is the most widely used pattern for business applications. All right? You're like, well, then why aren't we learning that instead of MVC? Because MVC is basically the pattern that's used almost exclusively with ASP.NET applications. All right, I think I mentioned this to you before. In fact, I'm fairly certain I did, but my guess is within 2 or 3 years, this class will change dramatically. All right, and I don't think we'll be teaching ASP.NET in here anymore. All right. In fact, if I had my way, we'd be changing the whole program. Okay, but it's me against 2 people, and I'm going to lose. All right, So the author says, I've already described the core design principles of MVC apps. All right. It says others interpret aspects of the pattern differently and have added to or adjusted it. So there are some other things in here as well. The first one, notice model, view, presenter pattern. So rather than model, view, controller, it's model, view, presenter. All right. You might think, well, who cares? Big deal. Well, notice what it says. It's designed to fit in more easily with GUI platforms like ASP.NET Web Forms. Okay? But what you get in here is you take some of the logic and you put it into the view. How much is up to you? All right? Again, you may end up with what's called a fat view in here. But the author says that when you do this, it says it takes a more direct relationship to a stateful view. There's two implementations. The passive view, in which the view contains no logic whatsoever. It's just a container. That's the way that the view works in a model view controller architecture. Or you can have what's called the supervising controller implementation, where the view may be responsible for some elements. So there may be some smarts that are built into the view. All right. As it says, the difference between these two approaches relates to how intelligent the view actually is. Either way, the presenter is decoupled from the GUI framework, and we're going to talk about coupling in just a couple minutes. All right. Not only is there a model view presenter pattern, but there is a model view model pattern. And again, you're all smart enough that you can read in here that it's the controller that's changing in all of these. All right? So as the author says, with the MVVM pattern, it was originated by Microsoft. All right? So it says it's used in conjunction with their Windows Presentation Foundation, or their WPF. WPF is another way of writing applications. I'm not going to lie to you. I've never done a doggone thing in WPF in my life. All right. So I'm not going to say anything more about it. Okay. So the next thing here is they talk about building loosely coupled components. All right. And I realize the good thing is everybody's here today. So if I put something on the board and I don't have to reproduce it here so it can be taped. But I think, I'm not speaking on a turn to say you'd all get this, that in an ideal world, if I was going to build an application that had 4 parts, all right, in an ideal world, I'd have part 1, part 2, part 3, and part 4. Now, again, in an ideal world, they might all be stuck together or whatever, but the reason I'm showing you that is that's a decoupled or a loosely coupled architecture. In other words, I could go in and I could change number 1, and it shouldn't have any direct effect on 2, 3, and 4. Does that make sense? All right. On the other hand, a lot of things are written like this. 1, 2, okay, let's do this. 3, 4. All right. That's more tightly coupled in that example. If I make changes to module 1, it could have a rippling effect where it changes 2, 3, and 4. The only thing that I can change without it affecting anything else are either 3 or 4. All right? And I've given the examples even like this you may or may not remember in the past, but as an example, let's just keep it real simple. I'm not going to use anything like this, but think about a calculator. All right? You all know how a calculator works, and as an example, you all know how the square root of a calculator works, right? On the other hand, if tomorrow they came out with a brand new calculator that figured out the square root in another way, as long as the button was the same on the calculator, and you hit it, you put a number and you hit it, and it gave you the right answer, you probably wouldn't care. All right? Because what they have done is they have decoupled the way you use something from how it actually works. The way that you use something, as you probably guessed, is typically referred to as your interface. All right. On the other hand, the way something works is typically referred to as the implementation. And in an ideal world, you should try to decouple those as much as you possibly can. It's not possible to totally do it because you're working on the same thing. All right. But the interface is what you show other people, and the implementation is how it actually works. Now, the author gives an example in here. I don't know if this is a good example or a bad one. All right. But I'm going to show it anyway. It's the one here right on the top of page 57. Okay? And if you notice, the box in the middle starts with the letter I, which means it's an interface. Okay? You may or may not remember back in the days when we talked about C# and we talked about inheritance, I mentioned that C# only allows for single inheritance. In other words, a class can only directly inherit from one other class. But a class can inherit or implement as many interfaces as it wants to or needs to. Well, why am I telling you this? Because if you look in here, the author is saying what we want to do is we want to basically decouple password reset helper and email sender, my email sender. You want to decouple those. So they say that the way they're going to do this is they're going to put this interface in the middle. But the problem is they're still coupled. All right? You may never be able to totally uncouple them or decouple or make them as loose as possible, but you want to work towards it. And that's what they're mentioning in here. So the author says interfaces help to decouple components, but there's still a problem. All right? It says C# does not provide a way to easily create objects that implement interfaces. So you end up with something the author says that looks like this. Now look at what they have here. They're creating a new thing called password helper. All right? And in here, they're creating this new interface called my sender. But what is it? It's one of these. So these things are still directly related to one another, is what the author is saying here. That's not what you want. You'd rather have something that kind of looks like this. You want to be able to replace, it says, the my email sender without having to change the reset helper. So you want to have a loose coupling between the two. So what we're shooting here is loose coupling. All right? And the author says, what I need is a way to get objects that implement an interface without having to create an object directly. It says the solution to this problem is called dependency injection. It's also known as IOC, or inversion of control. So if you look here, it says DI is a design pattern, just like MVC is a design pattern. But the idea behind this dependency injection, or IOC, is that it completes the loose coupling process. And the reason you want loose coupling, again, you want to be able to change X without having it have ideally no effect on Y. So you can swap components in and out and be able to use them. In an ideal world, you'd be able to write a library that would have virtually everything you were looking for in it. And when you created a new application, you could just grab those components that were in that library and do whatever you wanted to or needed to do with them. And that's pretty much what the author is saying right here. All right. So he goes through a whole big thing. It says there's two parts to this dependency injection pattern. The first is you remove any dependencies on concrete classes from the component. All right. And the second, it says you inject the dependencies declared. Okay. And I'm reading through this again for about the 5th time yesterday, and I'm thinking, okay, as the saying goes, clear as mud. We're going to do this in the sports store project when we have to. But I'm going to try to explain it and show it to you at that time what we're doing and why we're doing it. All right? All right. There's more to it. It says, once you resolve your dependency issues, how do you instantiate the concrete implementation of interfaces? You use what's called a dependency injection container. It says this is a component that acts as a broker. So the idea is to do this loose coupling. What you end up doing is you end up creating interfaces that act kind of as go-betweens between your classes. All right, that's taking something that's fairly complex and putting it into a sentence. All right, so I'm going to jump into the next section here on page 60 that starts talking about automated testing. And in this first section that's right in here, the author mentions that there's two basic kinds of unit testing. So let's suppose I'm working on a project. I don't care what it is, but that project's got 4 parts to it. Part 1, Part 2, Part 3, and Part 4. All right? So the first thing I want to make sure is as I finish these parts, I want to test them to make sure they're doing what they're supposed to be doing. So if you looked at this as being 4 different units, Unit P1, Unit P2, Unit P3, and Unit P4, my unit testing would involve testing each one of those units to make sure they work. All right? When I get done, I've got to make sure that not only does each one work, but that they work together. And that's referred to as integration testing. So probably the author gives a better definition than I just did, but near the middle of the page here on page 60, he talks about unit testing and he talks about integration testing. And he goes through a lot of examples. I'm not running through any of these. All right, why? Because I think that you might find them confusing. It's not what I want. But he goes through some examples. Okay? And notice what he has in here. He'll run a test and then he'll do what's called an assert in here. You can run those, and what an assert will do is it will come back and it will basically return true or false. To let you know when you're testing something, did it do what you think it was supposed to do, bless you, or did it not? Okay. All right. And the next thing that's in here, notice what it says. It's called TDD. And I may have mentioned this the other day. It's a very different way of thinking of things. You've heard of that saying, probably start with the end in mind. That's really what this is. Notice what you do. They give you like a 7-step process here. You determine what you need to do for your application. All right? Then you write tests. The tests will fail. You haven't written any code yet, but you write a bunch of tests. So you write a test, you run it, and it fails. Then you figure out what code you have to write so that it succeeds. You write that code and you keep testing it until whatever it is you're working on does succeed. All right? I know, and again, I may have told you this already. Sorry, I don't mean to bore you with all my stories, but I still will always remember the first project I worked on as a programmer. I had to write what's called a design unit document. And the way they were set up is I had to put each test on its own page. I was working with the phone company. Again, these were back in the days of rotary phones. Had to make sure if you dropped your phone, you'd still get a dial tone, etc. You know, if somebody got a hold of it and was doing things with the dialer or whatever that they shouldn't do, that it didn't break things. That kind of thing. The reason I'm telling you that is my design document had about 50 pages of text in it, and then about 500 pages where each page was a test. I'd say this is what I'm attempting to do. This is the test to do it. This is success. This is failure. And once it was accepted by the people I was working with, then I had basically a few months to run all 500 tests. All right? That's kind of what they're talking about here, but in reverse. Because there, it would be like, okay, I've written all these tests. I know they're all going to fail because I haven't written the code yet. I had to write the code first, then write the tests. That's the way most people are used to doing things. All right, but you know, this does work. I've been in projects with this, and it does work. And then the last thing they discuss in here is integration testing. And they give you a couple ways that it can be done. All right? Now that's it, but what I'm going to do is first I'm going to hand out, this is the written test for the chapter I just went over. And you're going to say, well, yeah, and the last page on here, there's 2 pages. The front page, front and back, are 10 questions, 5 points each. And the third page, which is a standalone page, I guess it's stapled. I've got a bunch of URLs that if you need help on anything, that you can go there and get whatever help you might need. So I want to take just a couple minutes to go over these. Again, I'm only expecting, for lack of better words, like a couple sentences or so on each. I don't need a book. I want it to be in your own words. If you notice, it even says here, and it's going to say it on every test, answer each question in your own words, please. All right? You've already done this, but I want you to do it again. What is meant by stating that MVC forces a separation of concerns? Number 2, what does the M mean? What does the V mean? What does the C mean? Very simplistic. Put it in your words. I want to make sure you understand it as we go on. All right? Then we just talked about the concept of a domain model. Again, explain that concept in your own words in a sentence or 2. Okay? Number 4, we talked about the model view presenter pattern. Give me that. Number 5, the model view model pattern. Give me that. Number 6, what is a loosely coupled component? I just mentioned to you what loose coupling is. All right. Number 7, what is dependency injection in terms of the model view controller? This is all in the chapter. Number 8, what is a dependency injection container or IOC? Number 9, what is test-driven development? Number 10, what is unit testing? Now, our author puts a lot of stuff in this book, but there are occasions when he talks about a concept but doesn't give them a lot of actual pages in the book. That's why I just gave you this. I'm going to keep doing this too. There's a bunch of, you click the hyperlink, you can get more information. For instance, there's view model. There's loosely coupled and tightly coupled. There's dependency injection, a couple of them. There's test-driven development, etc. Yes? Yes. All right. And again, like I said, there's a unit testing tutorial. If you say, I'd really like to know what unit testing is, all right, I might do it someday, I'd look at these last 2. In fact, if you look at the last one, notice what it is. All right, it's from guru99.com, which is a really good site. They got tons of really good stuff out there. But as it says, it's a tutorial where they have you create a small project and do some unit testing with it. All right. So spend the rest of the period today working on this all right, working on, again, your electronic portfolio. Tomorrow we'll go over Chapter 4. Chapter 4 has a project in it. When these chapters that we go through have projects, we're going to do those. And I want you to turn those in. This one doesn't. So there is no written homework for Chapter 3. Chapter 4 has a project. I believe 5 does, and I believe 6 does. All right? So that's what we'll be doing for the rest of the week. All right? Any questions? I'll tell you what, I'll do it like this. So there they all are. All right? Again, my hope is that we're through Chapter 6 by Friday. Next week, maybe the next 2 weeks, depending on how long it takes, we're going to go through an extensive database first, code example, and an extensive code first programming example. Okay? Then we're going to look at a project, a little mini project. Then we're going to work on, we're going to start on Chapter 7 and start on this sports store project. All right? That's about all I've got.